Hi everyone, thanks. My name is Ned Molter. I'm a postdoc here at Berkeley, and you're about to enter the Twilight Zone. Do 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 do. And if you remember that show, you are a lot older than me. I do not understand my own reference. Oh, I forgot to say what I meant to say. I'd like to really thank our entire team who made these observations possible. Their names are listed there, and then a few other people whose work I'll talk about. I'm excited to tell you about this Twilight Observing campaign that we started in 2017, and that was actually the last time that I gave a talk about it. So it's been 6 years since then, and I'm excited to tell you about all of the updates and improvements that we've made. Just a very quick outline of the talk. I know it's only a 12-minute talk. First, I'm going to tell you why it's useful for us to observe in twilight time and how that gives you extra science, quote unquote, for free. Then I'll tell you a little more about our program and some of the science that we've done. And then I'll spend quite a bit of time talking about our science operations and tell you how on the human power side, these things are very far from free. And then finally, I'll give you a little bit of an outlook. So the basic idea behind the program is that a lot of people in this audience who do really amazing science with, let's say, visible wavelength instruments with faint targets are often unable to use their morning twilight hours. You know, once the sky starts becoming bright, it becomes more and more and more challenging to observe at those wavelengths and for those faint targets. And so what we do is we do an instrument switchover to infrared imaging, and we go look at bright things, right, the planets. And solar system objects are really the ideal twilight observing target, right? They're extremely bright. They can themselves be used for wavefront sensing, so we can continue to do adaptive optics imaging. And they're highly time variable and interesting on multiple time scales in the infrared. So it's really the perfect thing to be studying if you want to do twilight observing. So our program aims at observing Io, Titan, Uranus, and Neptune during those morning twilight hours. I spun this program up in 2017, starting with NERC2 as a Keck visiting scholar under the amazing mentorship of Carlos Alvarez. In 2019, Aaron Redwing, who's a grad student at Berkeley, expanded the capability to the OSIRIS imager, also working with Carlos. And we've had over 100 activations since 2017, with something like 6% of nights seeing at least one of the two instruments carrying out twilight observations. 100 activations sounds like a lot, but it's actually less than a full night per year. And I'm proud to say that we've done quite a lot of what I consider high impact science with those hours, and I'll get to that in a minute. And those statistics are thanks to Isabel Kane, who is a third Keck visiting scholar working with Carlos. And I'll talk about her project in a moment. And yeah, massive shout out to the donors who make the Keck Visiting Scholar Program possible. I had an amazing time working at the observatory for a summer. We have a website. I would highly encourage you to check it out. We post our images very rapidly after they're observed, and so you can see in near real time what we're looking at. And that'll tell you more about our program and if you want to see our publication list and all of that. Okay, moving on to some of our scientific successes. In a series of two really amazing papers that include some data that I think is on our name tags today from a press release. Irandi Chavez, who was an undergrad working with us, was able to show that the brightness variability of Neptune, Neptune has displayed this global brightness variability over long time scales, and we've known this for a long time, but using the spatial resolution of Keck, she was able to show that that brightness variability is driven not by something in the average background haze, but actually by the level of cloud activity, and that cloud activity correlates with the solar cycle. And so that provides an interesting observation and a challenge for people who model cloud formation in ice giant atmospheres. Moving to Io, in this paper by Kat DeClear and colleagues, we were able to show that the spatiotemporal distribution of Io's volcanism suggests some interesting asymmetries in the leading to trailing hemisphere, especially in these brightest, largest volcano events, with important implications for how tidal heat dissipation works on tidally locked bodies. And then looking at my own work, way back in 2017, we were lucky enough to discover a cloud complex in the equator of Neptune during commissioning of this program. And it's very rare to see any clouds in Neptune's equator, and something of this scale had never been seen before. That's a typically, downwelling, quiescent part of the atmosphere. And thanks to the Twilight program, we were able to track the evolution of that storm over something like 6 months, and observe it break into multiple components and then eventually dissipate, which gave a lot of interesting observable parameters to the people who model convective storms in giant planets. All right, and then finally on the science side, I'm sorry I can't show you the web images today, but the Twilight program also offers really good synergy between Keck and other world-class observatories. And so this is an example. We observed Titan on July 10th and 11th with multiple instruments on Webb. And we saw this really interesting cloud complex, which you can see well in this third row near the North Pole region. But imagine you only had a single one of these multi-band observations. You would have no idea how this cloud system had evolved. And it turns out that with the Twilight data, we're able to say, well, it didn't really exist in the days leading up to this, and then it was observed with Webb. We'll have some amazing spectra in multiple wavelengths, and then it continued to evolve past there and get brighter and brighter. So I'm excited to be able to share more later. Okay, moving on to the operations side. I told you I'll tell you about how this is absolutely not free from a people power perspective. And I just want to give an absolutely massive shout out to the OAs. The way that our program operates in practice is, we don't know when we're going to get donated time. And we can't be awake every single night hoping that we will get time. And neither can the SAs, right? And so essentially everybody's asleep except the OAs. And so they run the show. They execute our observations completely on their own. And just a huge thank you to them for that work that they do. Yeah, please. And yeah, I shouted out Carlos already, but he's our man on the inside who keeps the observing scripts and the website up to date, past the Keck firewall when I'm not able to do that stuff. And then we have 3 PIs for the program from the major institutional partners: Imka, my postdoc advisor, Kat DeClaire at Caltech, and Ashley Davies at NASA, who propose for this every single semester. It is a big burden on the OAs, and so we've done as much as we possibly can to make their jobs easier. And this is including some interactive observation planning tools that are accessible through GUIs on our website that I wrote back in 2017. You can see, what's observable on which telescopes at what times. There are tracks across the sky. There's clear instructions. They're actually running the instrument is one setup command and one run command. And then, they can even see where the objects are relative to one another. And I want to point out that we didn't just make these. We've actually been iterating with the OAs for how to streamline this process more and more, which I think was very important. And then because the OAs are our observers, we also offer them co-authorship on all our publications. And you might have noticed on my science slides that those people were indeed included on those observations. And yeah, I just wanted to make mention that the Twilight Hours, anybody can go and propose for them. And if you have a good science case, I encourage you to do so. But to be clear, TAC approval for these things does not mean that Keck will make it happen. So when you consider observing, consider how you're going to actually ensure the longevity of your program. Okay, so moving ahead to the future, I'm really happy to say that the future of our Twilight program is infrared bright. I said I'd mention Isabel Kane's work again, and she's a grad student at UC Santa Cruz who's looking at feasibility of operating the scales instrument during twilight hours, both for our 4 science targets as well as some exoplanet stuff. And with an IFU, this would be really amazing because instead of having to cycle through 3 filters, which is usually all we can pretty much get on IO, and have a very rough estimate of volcano temperatures, you could get the entire wavelength range in one shot and have 50 data points on the volcano temperature, which obviously improves your science all that much more. So I think Isabel just gave a talk at Keck about this project. I don't know if it's available online anywhere. I probably should have checked. But I'm excited to see what comes out of this work. Okay, and then this is my last slide. I wanted to just say what, in my view, we need from the observatory for continued success, sort of leapfrogging off of your question in the last talk. And the big thing is wavefront sensing. The capability to use the planets themselves as a wavefront sensor is, to my knowledge, essentially unique among the 10-meter class telescopes, and that's thanks to the Shack-Hartmann wavefront sensor. The Pyramid wavefront sensor is amazing in many ways, but it doesn't work with our extended targets. The good news is that the real-time controller upgrades that are happening right now, Carlos and Randy tell me, should make it so switching between the wavefront sensors is robust and can be scripted in a one-liner, which means that our program can still happen. It'll just, require an AO switch. But yeah, Keck should continue to support the use of that sensor in order to continue supporting our program. If you're a PI on one of these optical wavelength instruments that sometimes donates their time, I encourage you to consider whether your morning twilight hours are really that useful to you. And if not, please do consider donating them. That's obviously incredibly helpful to us. And then finally, I don't know much about this. Like, I have no standing within these TACs or anything like that, but it's a little funny for both the TAC and for the proposers that we do 6 proposals per year to get 10 hours. So it might be worth considering different ways to support programs like this that do require so much additional work to continue operating. And with that, I'll just say thank you very much, and I'm happy to take questions.